This is part 6 of a series on decision trees. In this video, we will look at how to build a cart decision tree for classification. In the last video, we covered an overview of cart and how to handle categorical features. In this video, we will look at how to find the best split point using the Gini index and information gain, and use it to build an optimal cart tree. Now, let's look at the Gini index, information gain, and how to find the best split point. Let's use this small dataset to build a cart decision tree. This is a subset of the Titanic dataset. This contains 2 categorical features and 1 target variable. This dataset can be represented as a set of points in a feature space as follows. The classes of the P-class feature are on the x-axis, and those of the gender feature are on the y-axis. There are 5 data points where P-class equals 1 and gender equals male. The blue squares are data points where the target variable survived has a value of 1, and the red circles are data points where the survived has a value of 0. This is the root node of the decision tree. We will split this node into 2 child nodes. There are usually many possible split points to choose from. In this example, there are the following 3 candidate split points. Cart uses the Gini index to determine the best split point. The main objective is to minimize the Gini index at each node, resulting in pure child nodes. Alternatively, we can maximize the information gain calculated using the Gini index. Both are the same method. We will use information gain calculated using the Gini index to find the best split point. First, we calculate the Gini index of the root node. The formula for the Gini index is as follows. Out of a total of 18 data points, there are 8 blue ones and 10 red ones. Then the Gini index of the root node comes out as 0.494. Next, let's calculate the information gain for splitting the root node into 2 child nodes at candidate split point 1. At 1.5 in the P-class feature, split the root node into left and right child nodes. We calculate the Gini index of the left child node. The left child node contains 4 blue data points and 2 red data points for a total of 6 data points. Then the Gini index of this node comes out as 0.444. Next, we calculate the Gini index of the right child node. The right child node contains 4 blue data points and 8 red data points for a total of 12 data points. Then, the Gini index of this node also comes out as 0.444. Next, we calculate the information gain for this split. Information gain is the difference between the Gini index before the split and the weighted Gini index after the split. The Gini index of the root node is 0.494, and the weighted Gini index of the child nodes is as follows. Calculating this yields an information gain score of 0.050 for this split. Since this value is greater than 0, it is better to split the root node than to leave it unsplit. In the same way, we calculate the information gain for the second and third split points. The information gain for the second split point is 0.032, and for the third split point, it is 0.021. This is the largest value. Therefore, it is best to split the root node at the first candidate split point. We examined the reason for this in detail in the second video of this series. Simply put, a high information gain means the resulting child nodes contain data points that mostly belong to a single class, reducing the need for further splitting. In conclusion, this is the best split point for this node. Now that we have found the best split point for the root node, we can split it into a left child node and a right child node as follows. Since the left child node has only one candidate split point, it can be split as follows. Since the right child node has two candidate split points, we need to select one. As shown in the previous slide, we calculate the information gain for the two candidates as follows. Since this value is higher, we select this line as the best split point. We split this node into left and right child nodes as follows. Since each child node has only one candidate split point, we can use these to construct the final cart tree. The optimal cart decision tree for this dataset is as follows. Now that the tree has been built, we can use it to predict the class of test points. Let's say we have a test data point like this. We want to predict the target class of this test data point. Since the p-class feature is greater than 1.5, we follow the right branch from the root node. Next, since the gender feature is greater than 0.5, we move to the right branch from this node. Finally, since the p-class feature is greater than 2.5, we follow the right branch from this node. Then, we arrive at the final leaf node. This leaf node contains more red points than blue ones. Therefore, this test data point is classified as red, i.e. not survived. Next, let's see how to find the best split point for continuous features. The continuous feature age has been added to the dataset. There are many possible split points for continuous features. We need to find the best one among them. First, remove duplicate values. And sort them in ascending order as follows. Next, we calculate the average of each pair of adjacent numbers. Then, these values become candidate split points. Calculate the information gain for each candidate split point. Then, the one with the highest information gain is the best split point. Let's calculate the information gain at split point 24.5. Data points with age less than 24.5 are assigned to the left node, while those greater than 24.5 are assigned to the right node. The Gini index of the root node is your 0.494. The Gini indices of the left and right child nodes are 0.28 and 0.486 respectively. Thus, the information gain for this split is 0.077. Let's say this is the largest information gain among the candidates. Then, it becomes the best split point for the age feature. The information gains for the other features calculated earlier are as follows. Since this value is the largest among them, it is best to split the root node on the age feature at 24.5. Then, we recursively split each child node at its optimal split point until the Gini index becomes 0. So far, we have seen how to build a cart decision tree using the Gini index. In the next video, we will implement a cart decision tree from scratch.